Right on. Well, I'm really excited to be here. I've been listening either directly or in the background all day, and there's been some really interesting things. And what has really stood out to me in many of these talks is just how complicated some of the architectures and setups can be when you're talking about these production machine learning systems. So props to everyone here who is managing systems like that. I know it is not easy. So my little introduction that was made by Jim, thank you. I'm Zander, founder and CEO of Bytewax. And today I'm excited to talk to you a little bit about real-time machine learning and in specific real-time feature pipelines. So you might be asking yourself, in addition to all this complex architecture that I already manage and infrastructure, why do I need to add in additional complexity about real time? And the truth, which is its own session, is that you may not need to, but I'm going to share today how you can start thinking about that, adding real-time machine learning and real-time feature pipelines, and potentially bring major impact to your business with streaming data and real-time ML. So real-time machine learning is all around us today. You have recommendation systems like addictive TikTok videos. You have ads on many platforms, some of those of which are highly relevant and using many different inputs, streaming inputs. You have personalization on many of your favorite apps and websites. And then another good one is fraud detection. So when you're traveling, you get that text message right after you buy some train ticket or something like that in a foreign country. So that's a good example of many of the real-time machine learning systems we see today. But before I go on, a little bit more about me and why I'm here to talk to you today. So as was mentioned, I'm the CEO and founder of Bytewax. And before that, I'll talk a little bit about Bytewax, what Bytewax is. It's a stateful stream processor. It's an open source project. As Jim mentioned, it's Python, and we made it so it's easier to work with streaming data. But before Bytewax, I worked at GitHub, and before that at Heroku, and was working in many different data hats, I suppose, between data science, data engineering, machine learning, and machine learning infrastructure. Kind of migrated my way through a few of those things. And at the end, I was working on machine learning infrastructure at GitHub. And I left GitHub specifically to start a company focused on enabling real-time machine learning, as it was a big point of friction for us at GitHub. So I'm also, outside of working on Bytewax, a proud human and dog dad. I had my first daughter about 1.5 years ago, and I have a 8-year-old Aussie Shepherd Border Collie mix. This photo here is me trying to look cool, hiking up to go skiing. Outside of surfing, I also like to go skiing. And you can find me in the Bytewax Slack or in the featurestore.org if you want to chat more, or if you're happen to be in Santa Cruz where I live, send me a LinkedIn message and we can grab a coffee. Okay, on to the talk. Today's agenda, we're going to cover a little bit about background about real-time ML is, and then we're going to dive into how we can enable this with streaming data and stream processing. So moving right along here. So we all know that timeliness matters, but how much does it really matter? It has been shown to affect the bottom line of businesses directly and indirectly. In this case, we're talking about latency, but there's also freshness that is another aspect of this. So these statistics from Google, Walmart, and others may not look like much, but at their scale, it is millions or billions of dollars. But you may be thinking to yourself, oh, it's only for big companies. It can also affect smaller companies. Timeliness or latency can impact in additive ways how well your organization or big business will do with things like customer retention and customer lifetime value. But not only that, but in some of the tech-enabled businesses, it's a winner-take-all type of market. And you're competing directly to provide the most impact or value to the user, and this will result in either thriving or going out of business. So what does real-time machine learning really look like? Broadly, when we talk about real-time machine learning, it fits into one of two categories. And the first of these being offline training and online serving. What happens with the offline training and online serving is you, in a batch method, train your model, and then you promote it, and then you serve it in real time. And the other method is when both that training and serving happen in an online fashion. So you're constantly updating the model. So we'll kind of talk about what these are in more depth. This is a simplified version based on some of the diagrams I've seen today, but it's a sketch to illustrate from a high level how the online system works. So you have a mechanism to train your model in a batch fashion with some historical observations, and then is promoted to a serving layer where it can then make predictions. And then you have another system where you're receiving new data as it is generated, processing those observations, and then making them available to the serving layer so the fresh features can be used in the model inference. Obviously glossing over some of the little intricate bits of these systems in this. Another sketch in contrast to that is for online training and serving. So we have the observations coming into the model, and then you're making a prediction with those observations, and you're also updating the model. So an example of this that is fairly common is using some of the unsupervised methods. One of those, which is anomaly detection, various different anomaly detection algorithms where you can update the model incrementally. So today, though, we are going to focus on the feature side of real-time machine learning and how you can create real-time feature pipelines with Bytewax. Before we do that, I would like to divert a little bit just to talk about streaming data and how we can process streaming data. So we'll build a little pipeline to analyze a stream of data. I'm going to play a little video here. I hope it is easily viewable on your screens. Okay, so streaming data is all around us. I think the best way to kind of think about this, if you're a Python developer, is it's kind of like an infinite generator. And so that's what I'm like, what I was typing up in this video here. So we've created a little generator, and then the consumer or the downstream system will request if there is new information available in kind of a recurring polling manner. And so that in this video is us saying next. So you can think of the stream of data being the generator, and then the processor downstream is saying, hey, next, 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 and then it's changing that data for whatever purpose that you require. Okay, so the unbounded nature, which we were alluding to with that infinite Python generator, can really feel quite daunting. And in order to manage processing this data, we often use unique processing tools to chunk up or batch our data, or to maintain a memory of what has happened in the past. And the tools we use to do this fall into the realm of stream processors, and they're either referred to as stateful or stateless stream processors. The stateful ones are the ones that can retain stuff in memory, and one of which is Bytewax. Other tools you might be familiar with or heard of that can do this is Spark with their structured streaming part of the project, and then Flink and Beam are another common open source tools to do this. So all of these tools give us some semantics to connect to streaming data sources and process them in windows or micro batches to join different data streams together, filter it, enrich it, and then write it out to a sink, which in the real-time feature pipelines will be the feature store. So to illustrate what we're talking about with streaming data and this idea of like continually asking for if there's new data available and then processing it as a stream, we're going to make I'm going to show a little code snippet that basically pulls Hacker News API for new everyone's favorite news source, Hacker News. It continually polls Hacker News for new updates and then processes them in a streaming manner. We're going to do a little stateful operation here where we're going to count the number of comments on a story and update that incrementally, and then we'll just print it out to the terminal. Okay, so I have another little video here, so we'll run this and give it a second to get going. So Bytewax is a Python framework with a Rust processing engine, but you don't really touch the Rust processing engine much. So you're mostly what you see here is just Python code. It's nothing too fancy. The framework provides a lower level API that we've used here to build our custom input source where we're pulling Hacker News. And then we've also parameterized this data flow. So we can pass it an initial ID. So let's say that we had to go back in time and start from a certain period. We could find out what that story ID is. We can start from there and pass that through to our input. So in this data flow, we're setting a periodic input. So we're polling. I'm just going to take a quick pause here. So most clients that connect to streaming data sources, whether it's Kafka or Red Panda or a WebSocket, they're generally polling and asking if there's new data available. So we've just kind of slowed this down. And in this instance, oh no, press the wrong button here. Let me get to the right spot. Apologies. Okay, I won't be pausing it anymore. So every 15 seconds, we're going to call this, or Bytewax is going to call this input next item function that we'll show here in a second. And so we're just kind of like polling and saying, hey, do you have any new updates? Do you have any new updates? And we've kept in memory the max ID of the last time, and we'll just find the IDs between those and send them downstream. Redistribute them. So in the case of multiple workers, we can split them out, and then we'll process those individually as a stream of data. In this code, what we're doing is we're finding the root ID. So we might get a common ID and we have to traverse up the thing and get the parent ID. So we can do that with a map operator. The map operators are the operators are essentially the tools you can use to kind of control the flow of data throughout. You can think of each step as like a node in a graph. So in this case, we have our input that brings us many IDs, and then we flat map those. That's the operator. So we split them out and we process them one at a time. We've redistributed them again across workers. Then we've retrieved metadata. Then we've traversed back up this graph of comments, grabbed the key parent ID, and then we're using a stateful map where we have a builder function and a mapper function, which in essence is like every time I see a story ID for the first time, I'm going to do that build ID, which is make a story object. And then every additional time I see it, I'm going to update the count, and that's that mapper part. So I've left some print statements in those, so you can see when the story is created, and then the comment is updated. And then finally in this, we're outputting to the terminal downstream, we're outputting that count of comments. Okay, so that was all really cool, right? But what happens if the server room goes on fire and the whole thing collapses? Or if you want to do something more complicated, like many different types of windows or many different things in addition to what we showed there, which was just a simple comment count, it could be quite untenable, or you might end up with the wrong calculation. So what is generally advertised as a best practice, which we'll show next before we create our actual feature pipelines, is to split out. So in our streaming application, we had getting the raw data, doing some stuff with the raw data, and then doing this like stateful calculation and then printing it out. And it was all in one application. So the recommended best practice is to sort of split that out with something like Kafka or Red Panda in between. And the reason you want to do that is it writes to more durable storage layer and is backed up. And so if our worker or if our server room, like in this this graphic here, really actually goes on fire and our data flows go down, we can recover them and replay them from the correct offset and not lose any data for our feature pipelines downstream. So here's an updated update to our previous diagram of splitting out our calculations. So we've added some complexity to the overall amount of infrastructure that you have to manage. And that in this case is Red Panda, which is a Kafka API compatible streaming platform. You can think of the streaming platform as like the transport/storage layer for streaming data. So you can send the data through, but it also maintains some of what you've sent through at a durable level that you can replay it. So anyway, so we split this thing out. We've added a little bit of complexity, and the trade-off we're making for that complexity is we're able to do two things. One, have some more resiliency. The most common place our data flow might fail is in that calculations, those comment calculations, or the more sophisticated calculations. They may fail because we run out of, maybe it gets really big and we run out of memory, have to move it to a different machine, or maybe the data somewhat shifted and you have like some failure because a field changed or whatever it might be. So we have some resilience there. The other benefit is that we can have many consumers of the data we put in Red Panda without hitting the API many, many times. So we've saved ourselves the requirement of like overloading that single API to have many of these downstream pipelines. So moving on from here, we're ready to make some feature pipelines. So the first, you can think of what I've done so far as like, okay, let's get some data we're going to be using for making predictions. All of this is a little bit, you have to use your imagination because the feature is not really used and there's not a model downstream. But so we have pulled some raw data that we thought we could use to make some interesting predictions with the model. We've now created a pipeline to do something like that, to create one feature, which is probably not the right feature, but is count comments. And now we're going to split these things out so we can have a more of a production ready system, and then we can have many feature pipelines. So once more, we're going to have a little video that I'll try to talk through. So we're going to modify our previous example that you already saw to write the data out to fit into that architecture. So we're going to use Red Panda as the input, and as the streaming platform, and we already have that running in the background in this instance. So what we need to do to connect to Red Panda is we can use the Bytewax Kafka connector. So we'll replace the Kafka output, or sorry, the standard output where we're writing to the terminal. We're now writing to Red Panda. The reason it says Kafka output is because it's Kafka API compatible. So it's one works for both. So we replace that output step in the flow. And now there's a couple more things that we're going to do after we replace that output step. One of which is we don't need our stateful map count comments anymore. We're going to put that in a separate feature pipeline that's going to be taking input from Hacker News raw. So we can remove that from our code, and we'll remove the corresponding story class that we made and the update count. And what we're going to do and what we're going to replace that with is a serialization step. Red Panda requires that our data comes in as byte string. The topic requires it comes in a byte string, so we just need to serialize our data into a byte string and then pass it through. So we'll JSON serialize it and then into bytes, and then we can send it through, or it will work sending it through that Kafka or the Red Panda output. So here you see me in the console UI, create the topic, Hacker News raw. We'll skip over the details of what the topics are and partitions and everything like that. So we have our topic. Now we can start writing data to it. So we run our Hacker News flow, and when we find out there's an update, we shove that into Red Panda. And in the Red Panda UI, you can do some cool stuff, like you can see the data. So we could leave this thing running, and yay. Now we can move on to the next part, which is how can we create these feature pipelines from Red Panda. So that's also a nice little video here. And our data flow has been chugging along nicely in the background, and we have a bunch of stories and comments in this Red Panda topic. And now we're ready to write some features against this to first do what we were previously doing, which was count comments. So luckily, Bytewax has a nice Kafka input adapter or connector that can be used with Red Panda. So here we can add it in place of when we had the Hacker News input that we built, where we built that custom class. Here we're just going to use one out of the box. And then we're going to take that stateful map code that we used before, and we're going to throw it in here as well. And then we can use that to count our comments. And now we're going to put it back into Red Panda. And before we do that, we will serialize the data again. So we deserialized, counted, and then we serialized it and wrote it back to Red Panda. This let's skip ahead here. I went a little bit maybe too quickly here. So let me explain what's going on quickly, and then we'll. So we added an input in our data flow code that you can see up above here. We added the Red Panda input. So now we're consuming, instead of consuming from the custom class that we wrote, which was polling an HTTP endpoint, we're consuming from Red Panda, and then we're deserializing that data because we serialized it on the other side. Now we do our stateful map, which is counting comments. So we create a story object and then update that story object with the count of comments. And then we now we end up with data in the format of story and the count of comments. We serialize that once more so that we can into a byte string, so we can send that to Red Panda, and we're sending it to a new feature called HN feature 1. We've run this thing in the video already. It started from the beginning of the Kafka topic and has crunched through all the data. We have a logging step in here, so it's logging some of these comments along the way. I think I recorded this 2 days ago or something, so there's probably, I don't know, maybe there's something here, something about meta headsets. And then we can go back to the UI. Oh. Well, what I wanted to show, which is I mispressed here. You go back to the UI and you can see the story and the running count of comments, which is going up and up and up. So that's that. Someone else today has already showed how you can plug these sort of things into the HopsWorks feature store, but that would be our next step. Say we actually had a feature that we wanted to use with our model, and we were going to predict the, I don't know, trending hacker news or something. We could do that with HopsWorks. There's a tutorial on it that has Bytewax in the HopsWorks tutorial repo. But basically you would tell HopsWorks what the schema was and what the define that feature, and then you can kind of point it to the Kafka topic. So that was a lot, and it was pretty fast, but I managed to make it in the time with no time for questions. If you want to check out the code, you can find it on my GitHub, AW Maths and Guide Periodic Note News, and it will be a guide shortly on our website because I'll make it a guide there, and then you can find us at Bytewax/Bytewax. Yeah, thank you, everyone.
Brilliant. Thanks, Zander.